unit. Pascal is the absolute unit for pressure. Well, we can now use the pressure equation to obtain the atmospheric pressure at sea level. Now, we now know that pressure exerted by the atmosphere is the same as the pressure exerted by a column of mercury of height 760 millimeter. And what is the equation for pressure we derived some time ago? Pressure exerted by a fluid at a point is H rho G. That means pressure at B due to the column of mercury standing on it is the height of mercury multiplied by the density of mercury multiplied by G. Now, do you know the density of mercury? Mercury is approximately 13.6 times denser than water. What is the density of water? Density of water is 1 kilogram per liter, which is 1,000 kilogram per meter cube. If you take a container which is 1 meter long, 1 meter wide and 1 meter tall, the mass of water that container will hold is 1,000 kilogram. So density of water is 1,000 kilogram per meter cube. And mercury is 13.6 times denser than water. So what is the density of mercury? It is 13,600 kilogram per meter cube. And now, did anybody ask me while you were listening to the lecture, why did Torricelli use mercury, such a poisonous substance, for this experiment? Why couldn't he use water? Now, do you have an answer for this? Why did Torricelli use mercury and not water? Well, in order to balance the atmospheric pressure, what is the height of mercury that balances the atmospheric pressure? It is 760 millimeter. If you, instead of mercury, if you use water, what will be the height of water that will balance the atmospheric pressure? It will be 760 times 13.6. It will be approximately 10 meters. Torricelli had to use a tube of approximately 10 meters. Well, is it possible to hold an experiment with such a tube? It's not practicable. Mercury is the most practical substance for this experiment because of its high density. Okay, now pressure exerted by a fluid at a point is H rho G, where H is the height of the fluid standing at that point, rho is the density of that fluid, and G is the acceleration due to gravity. The density of mercury, rho mercury, is 13,600 kilogram per meter cube. Therefore, what is the pressure exerted by 760 millimeters of mercury? Remember, 760 millimeter is 0.76 meter. So, what is the pressure exerted by 0.76 meter of water? H is 0.76 meter. Density of mercury is 13,600 kilogram per meter cube. And G is 9.8. That is 1.01 times 10 to the power of 5 Pascal. This much is the pressure exerted by the atmosphere, and we call it 1 atmosphere. A pressure of 1 atmosphere is 1.01 times 10 to the power of 5 Pascal. We will use this value very often in physics too, so keep track of this value. 1 atmospheric pressure in absolute unit is 1.01 times 10 to the power 5 Pascal. Alright? Let me ask you, how many millibars are these? Well, we talked about it. 1 atmosphere is 1011 millibars. And so, if I ask you, 1 millibar is how many Pascal? It is approximately 1000 Pascal. Well, work it out on your own. So, when the atmospheric pressure falls, now what happens if the atmospheric pressure falls? If the atmospheric pressure falls, the level of mercury will also fall correspondingly, because the pressure at A will be always equal to the pressure at B. That means if there is a low pressure in the atmosphere, the level of mercury in the tube will fall. On the other hand, if there is a buildup of pressure, when there is a high pressure, the level of mercury will increase. Have you heard of meteorologists talking about falling mercury? When he's talking about a falling mercury, he's talking about a low pressure. Especially when you live in Florida, a low pressure is always associated with, well, depression, which will cause finally tropical storms, and hurricanes are all associated with low pressure. So when the mercury falls, it's an indication of low pressure. When the mercury climbs, it is an indication of high pressure. All right. Let's now talk about a manometer. A barometer is used to measure air pressure, atmospheric pressure. What is a manometer? A manometer is a device used for measuring gas pressure. Now, this is a simple manometer. What is it? It is a simple U-tube. One end of the U-tube is connected to a gas cylinder, and we want to measure the pressure of the gas cylinder in there. The other end is open to the atmosphere. Now, inside the tube you have mercury. Now, tell me, what is the pressure at the top of mercury in the open part of the tube? What is the pressure there? It is open to the atmosphere, which means the pressure there is the atmospheric pressure. So, a manometer consists of a U-tube that contains mercury. One end of the U-tube is connected to a gas supply. The other end is open to the atmosphere. Now, if the levels of mercury, suppose this is the manometer before we connect it to the gas supply. You notice that the levels of mercury at both the limbs of the manometer are the same. That means both are atmospheric pressure. So, when the pressure is the same, the levels of mercury must be the same in both the limbs. If the level of mercury in the limb connected to the gas is lower, suppose this is the end connected to the gas supply, and that the level of mercury there is lower. What does that indicate? It indicates that the pressure of the gas in the cylinder is greater than the atmospheric pressure, because the pressure inside the open tube will be the atmospheric pressure. Now, can you measure this pressure? How much is this pressure? You know that the atmospheric pressure is the same as 760 millimeters of mercury. Pressure exerted by 760 millimeters of mercury. The pressure at C, this is the point C. You know that the pressure at C is the same as the pressure at B, the same horizontal surface. And what is the pressure at B? Pressure at B is the pressure at A plus the pressure exerted by this much column of mercury. Now, this much column of mercury has a height h. Therefore, we can say the pressure at B is atmospheric pressure, which is the pressure at A, plus the pressure due to h centimeter or millimeters of mercury. Is that right? So the gas pressure now equal to atmospheric pressure plus pressure of h millimeters of mercury. So you can measure the pressure of the gas supply straight away like that. On the other hand, if the level of mercury in the limb connected to the gas is higher, like this, what does that indicate? Well, the pressure on the surface which is open to the atmosphere is atmospheric pressure. Pressure at A is the atmospheric pressure. Therefore, pressure at C will be less than the atmospheric pressure. Is that right? That's the reason why it is higher. Less by how much? Less by the pressure exerted by this h millimeters of mercury. So gas pressure now is atmospheric pressure minus the pressure exerted by this h millimeters of mercury. Now, depending on the level difference between the mercury in both limbs, we can calculate the pressure of the gas supply. And this is a very useful way of